Hello everyone, so today I will be doing the VCAA 2023 physics exam, and this video is just for the multiple choice. I will be doing extended response soon enough, so right after this hopefully. So let's get started now. So question number 1. So one type of loudspeaker. Okay, so just for the heads up, I have not seen this exam before now, so I just got my hands on it. So if there's anything wrong, just let me know down in the comments. Okay, so let us continue. So one type of loudspeaker consists of a current carrying coil with a radial magnetic field as shown in the diagram below. Okay, X and Y are magnetic poles and the direction of current I in the coil is clockwise as shown below. Okay, the force is acting into the page. Which of the following statements correctly identifies the magnetic field polarities of X and Y? Right. So it can't be C or D either, because they can't both be north or south pole. It can't be B either. So I think it's going to be A for this. Okay. Moving on. So question number 2. The diagram below shows two charges, Q1 and Q2, separated by a distance D. There is a force F acting between the two charges. Which one of the following is closest to the magnitude of the force acting between two charges if both D and charge on Q1 are halved? Okay, so we know that F is going to be proportional to Q on D squared. And we also know that our Q is halved, so is our D. So that would just become half times 4. So that would mean that 2. So our force will now become 2 twice, basically. So answer is going to be C. The space scientists want to place a satellite into circular orbit where the gravitational field strength of Earth is half of its value at Earth's surface. Which of the following expressions best represents the altitude of this orbit above Earth's surface, where r is the radius of the Earth? Okay, so let's say that this is going to be our Earth, and it has its own radius. Let's call it r. And now what we're basically finding is how far do we have to go, let's say x. Okay, this is what we are finding. However, what we are going to do is we're going to find the whole radius over here till this point over here, and then subtract it from this radius over here. So that's going to be our logic to approach this question. So G equals to Gm on r squared. So we can say that G is inversely proportional to r squared because G and m are just constant. So if G is halved, that means 1 on r squared. So that means that r squared is going to be 2. That means r is going to be square root of 2. Right, so if G is halved, our r is going to be like root 2 of the radius. Okay, so our final answer would be root 2r, because that's the whole distance. And then take away this r over here is going to be our x, so that is going to be our answer. So answer is going to be C. Okay, moving on. So the diagram below shows the force versus time graph of the force on a tennis ball when it is hit by a tennis racket. The tennis ball is stationary when the tennis racket first comes into contact with the ball. Which one of the following is closest to the impulse experienced by the tennis ball as it is hit by the tennis racket? Right, okay, so the impulse is going to be the area under this graph. Okay, so let's look at some obvious boxes first. So we have one over here, and we have this huge line of boxes over here. Wait, let me choose a different color because this is just blending in. So this is our box over here, and then this is our box, and there's like a huge amount of boxes over here. And there's like side chunks and this and that. So first I'm just going to focus on these boxes that we constructed. So what is our scale for the t-axis? So this axis over here. So 1, 2, 3, 4, 5. So it's going to be 0.01. and this is going to be 50. Okay, cool. So we have 1, 2, 3, 4, 5, 6, 7. So 7 times 0.01 times 50. How much would that be? I think it's going to be 3.5, but I'm just going to quickly check. So 7 times 0.01 times 50. Okay, yep, so it's going to be 3.5 Newton times second. Now, is there an option for 3.5? I don't think. Okay. Okay, so there is no option for that. So what we can do is maybe consider the other area and start approximating. So what I'm gonna say is, I'm gonna say maybe that this is going to make up, these two is going to make up for like just over a little bit of the box. So I'm gonna say that, actually let's just assume that this two make up a just over the box, yeah, as I said. So just a little bit more than a normal box, so just a little bit more than that. So let's say that these two make up about 1.2 of the box, just a rough decimal. That means that this two over here will make like, because these two look similar to half of the boxes, I'm gonna say these two make up 1. Let's say this area over here, so this chunk, it looks like it's going to make it wait, so how much is this? 7 plus 1.2 plus 1 is going to be 9.2. Okay, you know what? I'm gonna go with that. So let's say I'm gonna say 9 times 0.01 times 50. So that gives me 4.5. So I'm just gonna go with 9 for now rather than counting and trying to be very accurate. So what I'm gonna do is, okay, so we got 4.5 Newton when I took like 9 squares. I think I'm very well convinced that it's going to be 5 at this point. It can't be 10 or 50. That's just like way too big considering for this graph over here. And 0.5 is like way too small. So I think it's gonna be B. The diagram below shows a stationary circular coil of conducting wire connected to a low resistance globe, a uniform constant magnetic field, a uniform and a constant magnetic field. Okay. Okay, wait, hold on. Okay, so I forgot to read this. So question 5 and question 6. Okay. So question 5. The magnetic field is switched off. Which one of the following best describes the globe in which of the following best describes the globe in the circuit before the magnetic field is switched off, during the time magnetic field is being switched off, and after the magnetic field is switched off? So I'm gonna say it's going to be off, on, and off, because it has to like change. So it's going to be on during, and yeah, so I think it's gonna be A. A is gonna be our answer over here. The radius of the coil is 5 centimeters, and the magnetic strength is 0.2. Okay. The coil has 100 loops. Assume that the magnetic field is perpendicular to the area of the coil. Okay, so full force. Which of the following is closest to the magnitude of the magnetic flux through the coil of wire when the magnetic field is switched on? So we know that flux has a formula of B times A, and our B is going to be 0.2, and A is going to be like, it's a circle, so pi r squared, so 0.05 squared. And let me punch that into the calculator and see what we get. 0.2 times pi times 0.05 squared. So we get 0.00157, so that is like 0.0016 Webers. So I think it's going to be A. Okay, question number 7. So, an oscilloscope is connected to the sinusoidal AC voltage source. The resulting trace on that screen is shown below. Okay, One vertical division on oscilloscope screen represents a potential difference of 20. So one vertical division. So this is 20. So that means this is 1, 2, 3. So this entire thing is going to be 60. And one horizontal division represents a time interval of 10. So this is going to be 10. 10 milliseconds, by the way, not seconds. So we have to convert, I think. Which one of the following is closest to the both peak-to-peak voltage and frequency of the signal shown in the diagram? Okay, so the frequency is going to be 1 on period. So what is the period? So 10 milliseconds plus 10 plus 10 and then plus 10. So 40 milliseconds is going to be our period, and that is like 0.04 seconds. So our frequency is going to be 1 on 0.04, which is going to be 1 divided by 0.04, so 25 hertz. So that's going to be our frequency. So we can cancel out options A and C just like that. And our peak voltage, peak-to-peak voltage, is going to be 2 times V. So 60 times 2 is going to be 120. So answer is going to be D for this. Question number 8. At a swimming pool, Shahrukh and Sam, shown below, step off the low dividing board at the same time. Over the small distance they fall. Air resistance may be ignored, okay. Shahrukh and Sam have masses of 80 kilograms and 60 kilograms respectively. Which one of the following best explains what happens to Shahrukh and Sam as they drop straight down into the water? Shahrukh reaches the surface first because she has a larger mass. No, that is not going to be true. The net force on Shahrukh is larger than that on Sam, so Shahrukh reaches the surface first. No. They both reach the surface together because they both experience the same downward force. Well, this part over here, this part of this option is correct. They do reach together. However, they do not face the same downward force because one has a mass of 80 and the other has a mass of 60, so mg is not going to be equal as the masses differ. So it can't be option C. So they both reach surface together because they both experience the same downward acceleration. Yeah, that is correct. Okay. Next question. So an engineer is designing a banked circular curve of radius 25 meters in a new bicycle velodrome. Diagram A shows the bicycle approaching the bank section, and diagram B shows the front view of the bicycle moving out of the page as it rounds the banked band. The bicycle is traveling at 11 meters per second on bank section. At this speed, there are no sideways frictional forces between the wheels and the road surface. Which of the following is closest to the angle of the bank band? So from top of my head, I think there's a formula that tangent theta is going to be v squared on rg, and we are finding angles, so theta equals to tan inverse of v squared on rg. So that is going to be tan inverse of 11 squared, because that's the velocity, and what was the radius again? 25. So 25 times 9.8. So that is going to be, just calculating it in my calculator, so 11 squared divided by 25 times 9.8. So 26.28. So 26.28 degrees. And that is closest to 26. So I'm going to go with option C here. Okay, so use the following information to answer question 10 and 11. Okay. A force versus compression graph for a car spring is shown below. Okay. Which one of the following is closest to the spring constant of this car spring? Right, so this is in kilonewtons and this is in millimeters. So we have to convert both of them into the standard units. So kilonewton to newton is times it by 1000, so 40 times 10 to the power of 3. And from millimeter to meter, so we have 8 millimeter, we are going to have 0.008 meters if we convert. And now we can just find the spring constant by dividing them. So let us do that real quick. So 40 times 10 to the power of 3, just punching in my calculator, divided by 0.008. So I get 5 times 10 to the power of 6. Okay, so this is going to be our answer over here, D. When the car is sitting on a level surface, the car is compressed by 4 millimeters from its natural length, as shown below. Okay, as the car goes over a bump in the road, the car spring compresses an additional 4 millimeters from the initial compression of 4 millimeters to a total compression of 8. Yep. So which one of the following is closest to the additional potential energy? So additional potential energy, not the total, but the additional one, stored in the car spring when the car goes over the bump. So right, so what we have to do is we have to first find the spring potential energy for the whole 8 millimeter compression and then take it away from the 4 millimeter initial compression, because they're just asking for the additional one. They're not asking for the full compression. So what we can do is first find the whole compression with 8 millimeters, so half times k, which we found to be 5 times 10 to the power of 6 times 0.008 whole squared, and that is going to be 0.5 times 10 to the power of 6 times 0.008 squared. So that is going to be 1.6 times 10 to the power of 2 joules. And the initial potential, so now the initial spring potential energy generated by compression, so half times 5 times 10 to the power of 6 times 0.004 to the power of squared to the power of 2. Okay, that is going to be 4 squared. So that is going to be 4 times 10 to the power of 1. So we just subtract these two, so 1.6 times 10 to the power of 2 minus 4 times 10 to the power of 1. So we get 1.2 times 10 to the power of 2 joules. So answer is going to be B. Tricky question. So moving on, a physics class is investigating a dispersion of white light using a lens as shown in the diagram below. Okay? A student observes the rays K to P that have been refracted by the lens. Which of the following correctly identifies the color red, green, or violet of the rays K to P? Okay, so I know that red diffracts the least. So by that I can say that M and N is going to be red. Let's see if that is going to be an option. So okay, so they have M and N as red here, and no other option, and none of the other options. Okay, so that just makes it quite easy and safe to say it's going to be B. Okay, cool. A physics student hears a clap of thunder shortly after observing a flash of lightning. Which of the following statements best describe the sound associated with the clap of thunder and the visible light associated with the flash of lightning? So both sound and visible light are examples of transverse waves. No, that is not going to be the case because sound is a longitudinal wave. So no, both sound and the visible light are examples of longitudinal waves. No, sound is an example of transverse. No, sound is an example of longitudinal wave and visible light. Okay, that is good. So option D. Polarization of visible light provides evidence that electromagnetic radiation can be explained using a transverse wave model for light. So option B. Okay, so question 15. Wow, okay. Two ambulances A and B are traveling along a straight road, both with the same constant velocity. Both ambulances have their sirens on and sound produced are identical and have a constant frequency. Okay, so ambulance A is traveling directly towards the stationary observer, while ambulance B is traveling directly away from the stationary observer, as shown in the diagram below. Which one of the following best describes the frequency of each siren as measured by a stationary observer, compared to the frequency of the observer would measure if ambulances were stationary? The observer measures each siren's frequency to be lower, nor each siren's frequency to be higher. No, there has to be difference. So the observer measures the frequency of ambulance A siren to be lower and frequency of ambulance B siren to be higher. So A is going to be lower. No, it's going to be the other way around because, yeah, it's going to be like that. This is going to be like the sound wave or whatever around that. So this is going to be like going away, and since this is approaching, yeah, this is going to be like, yeah, higher frequency. So it can't be C, meaning it's going to be option D. Okay. Okay, so just checking. Observer measures frequency of ambulance A siren to be higher. Okay, that is correct indeed. Water waves traveling at a constant speed and hitting barrier can change direction as shown in the diagram below. Okay, which one of the following best describes this phenomenon? This is going to be diffraction, so option A. Which one of the following statements best explain why it is possible to compare X-ray and electron diffraction? X-ray can exhibit particle-like properties. No. Electrons can exhibit wave-like properties, so that is true, yes. Electrons are a form of high-energy X-rays. Both electrons and X-ray can ionize the matter. I'm unsure about options C and D to be true. So I'm just going to go with B. Play safe here. I'm going to go with B. Which of the following statements best describes the type of light produced from different types of light sources? So light from a laser is coherent and has a very narrow range of wavelengths. That is indeed true. Light from an incandescent lamp is coherent and has a wide range of wavelengths. Light from an incandescent lamp is incoherent and has a very narrow range of wavelengths. No, this is not true. Option B and C are not quite. Yeah, no. Light from a single color light emitting diode is coherent and contains a very wide range of wavelengths. Nah, I think it's going to be option A for this. So question 19. The diagram below shows the spectrum of light emitted by a hydrogen vapor lamp. The spectral line indicated by the arrow on the diagram is visible in the visible region of the spectrum. Okay. Which of the following is closest to the frequency of the light corresponding to the spectral line indicated by the arrow? So we know that F is going to be speed of light on wavelength. So it is going to be 3 times 10 to the power of 8 over... hold on, is this like 650 or 660? I'm just going to go with 660 times 10 to the power of -9. So let me just put that in my calculator. So 3 times 10 to the power of 8 over 660 times 10 to the power of -9. So 4.54. Okay, so it's like 4.54 repeating to the power of 14. Yeah, okay, so the closest one is just going to be 4.6 times 10 to the power of 14. Yeah, so option B. Okay. Heisenberg's uncertainty principle can be used to explain the results of a single slit diffraction experiments for the electrons. This is because Heisenberg's uncertainty principle fixes the size range of the slit to be used. States that the electron's exact position was predictable after passing through the slit. No, because there is an uncertainty literally in the name. States that each electron's actual position after passing through a slit was only known within a wide range. This is true. States that if electron's momentum was known, its position after passing through the slit was also known. No, can't beat that. I think it's going to be option C over here. I'm going to go with C. Okay, so that concludes section A, and I will be sure to upload section B as soon as possible. So thank you for watching. I hope you all went well, and good luck for any future exams you have.